Broadcast is now starting. All attendees are in listen-only mode.
Hey guys, can you hear me and see my screen? There's a chat window, so you can quickly confirm me there. I repeat, my screen is visible and am I audible? Please confirm in the chat window so that we can start the session. Do we have anyone? I can see two names, but I'm not getting any response from them. Aditi and Suruchi. Perfect. Okay. So quickly, I'll recap what we have discussed in the last session and what we're going to cover today. So we are into statistics part, and we are diving into mathematical section of data science. How we are going to apply this maths on our algorithms, machine learning algorithms, and how we can create a logic without using any programming concept. Okay, so programming is helping you to write a set of instruction, but main logic behind any model, behind any machine learning library or algorithms, it's all maths. Uh, what we have seen so far, we have covered central tendency, we have seen random variables, discrete and continuous, and we know what is a discrete and what is a continuous variable. Now, today we'll start with the distribution concept. Today we'll start with the distribution concept, and that is, I'll say, one third of statistics. It's a one third of state. So pay attention here. Normal distribution. There are 100 different types of distribution we have. Okay, 100 different distributions are there, but normal distribution is very useful for normalizing our data and standardizing our data. So whenever we need to standardize data, what is known as a standardization, we have often seen how we are plotting our x and y axis, right? Whenever I use any visualization technique using Python, so there are two different libraries, Matplotlib and Seaborn. So when I plot my data, and you often encounter that your data is looking like this, which means obviously it is starting from zero. So this whole curvy area is one, and whenever you see there's a slight curve towards down, so this is nothing but my mean. This is nothing but my mean, which we denote as a mu mathematical sign. And then we say whatever value we are getting at the left side, and whatever value we are getting at this right side. So let me say left and right. These are symmetrical. So this concept is known as a standardization. We standardize our data. We'll see where we are applying in real-time applications where we are using this data standardization concept or data normalization concept. So normal distribution is also known as Gaussian theorem. It is also known as Gaussian theorem, because there was a scientist named Gauss. He designed this theorem, and hence we call it's a Gaussian theorem. It looks like a bell curve, right? It looks like a bell curve, hence this is also known as a bell curve. It is also known as bell curve, or I can say it represent their visualized format data in a bell curve format. So it is also visualizing data in bell curve format. So what is the mathematical intuition of this? what is the formula for normal distribution and how this normal distribution formula is derived. Okay, so uh, I can take any random variable. I'll say x is my random variable, and random variable, this can be from anywhere. Let's say I'm checking population, total population of a city. I'm checking average income. I'm checking uh, people's age. I'm checking insurance policies. So this variable can come from any data set. This is my random variable. And whenever I say random variable, you can understand there are several data points which are coming from some applications. And this random variable says if this random variable is normally distributed. Okay, so this is my data. Whatever curve you're seeing in this rate format, they are my data, continuous data. And uh, this distribution is normally distributed. So whenever you found n is the normal distribution sign. And what is the mean? What is the mean of this normal distribution? What is the value of this? And what is the value of their variance? We have seen this two formula in a central tendency, guys. How to get the arithmetic mean, how to check the mean, and how to check the variance. So there we have seen encounter sample variance and population variance. So this mu square is a variance. And whenever I say any data is normally distributed, okay, when we're claiming that data is coming from this application is normally distributed, which means I'm saying that this x is having normal distribution data with the mean of 0 and standard deviation or sample variance of 1. When I say I have normally distributed with mean 0 and sample variance 1, which means this data is coming from a normal distribution. First thing I need to know, that whatever data I'm dealing with, whatever data point or data set I'm dealing with, this is coming from which distribution. We need to find out. Once this question is clear, we know the answer of this question, that this is coming from which distribution. You'll find in upcoming session many distribution. There can be a hundred of different distributions. And why this distribution is important, because in I'll give you an example. In pre-computer eras, right, like 1950s and 1960s, 1940s, whenever any engineer, any designer, any statistic guy, they want to create any model. Let's say they want to design one DEM. So when they want to design one DEM, how they will calculate it? There is no Python, there is no programming, nothing is there. So they used to follow the concept of distribution, and they used to fit whatever data they are collecting. Let me take one example here. So I want my task is to build my task is to build a DEM. Okay, my task is to build a DEM, and I need to find out the upstream level of this water. And this task I am doing not in 2020, which is the current year. I'm doing this task in pre-computer eras, 1950s or 1960s. How do I calculate this? Because there is no machinery process computer design to calculate, get the data and calculate it. So my first critical task is to collect the data point, because in nowadays we are living in the world of this social media, e-commerce website, right? We can collect data as much as we need for calculation. We can use any public API to get the data and start using those data. Just like today, if I want to get the data of COVID-19, I can go to the government site, I can collect all the data, whole database is available. But in this time, data collection is very difficult. So they used to store their data in their chart. They used to often refer the chart, and then this is my data point, this is my row number 1, let's say row number 2, row number 3, and likewise I have total 500 data points of last 20 years. And this data is coming, what kind of data is this? So when I'm building a DEM, when I'm building this DEM, I'm not building this for just 5 years or 10 years or 20 years. I'm building this for hundreds of different years, right? So when I'm building this for hundreds of different years, or for another century, I need to know a couple of questions. First question, what should be height of this dam? Because this is very first information which I need, so that I can check my total upstream. This is my water upstream coming towards this, and I can create a different channels, different gates there based on the water upstream, and I can channelize this water, right? I can channelize this water towards villages, or I can use this for hydropowers, electricity generations, and couple of other activities. But first thing, I need to know what is the height, so that I can predict the number in a centimeter or in a meter. Now immediately there is another question which I need to know, that what is the maximum in last this 20 years, what is the maximum daily rainfall? Yeah. So out in this 20 years, I need to know what is the maximum daily rainfall. Once I know this, once I know this, say this is my random variable, means all the rainfall data, all this rainfall data is stored in a X, and I am saying I will check total how many days more than 22 centimeter of rainfall we have observed or we have experienced. I need to find out the probability of this. I need to find out the probability of this question. So maximum daily rainfall, I need to know this number. So using this 500 data point, let's say there is a total 500 data point, and I only found 3 days where my data, my daily rainfall is more than 22 centimeter. There are only just 3 data point out of 500 where this probability can happen. Okay, so if you get to know probability of this, let me use my calculator to get the probability percentage. So this answer is coming as 0.006. Okay, this is coming as 0.006. This is the probability value, and if I say in a percent, I'll say this is 0.6%. 0.6% is a probability that maximum rainfall can happen more than 22 centimeter. Now question is, can you really rely on this just 3 data point? Because your data collection is very less. This concept is coming from percentile or probability, right? If I use a concept of percentile, like 25th percentile, 50th percentile, 75th and 100, but I am relying on just 3 data point, which is definitely a big risk to creating this. So what I'll do, I'll not use this percentile or any percentage concept. What I'll try to do, I'll try to fit all this 500 data point in some of the distribution using the charts. So all the values already there. I'll try to define a chart, I'll try to fit the data, and then I can say I'll apply this distribution concept to build a dam, right? So this distribution are helping us today in a machine learning world also to standardize our data and answer many questions, like where I can use this normal distribution concept to answer. Let's say first question, how many people how many people height is in between 160 centimeter to 185 centimeter from whole population of India? If I want to answer this question 160 centimeter to 185 centimeter, I need to know just two things, guys. I just need to know two things, because what is the what is the normal distribution argument here? Mean and sample, mean and population variance. So once I know these two things, once I know the value of this two, I can answer this question. I just need to know this two part. I'll tell you how to calculate this. Just bear with me. Second question, people life. So find us number of people, find us number of people live in between 50 year to 80 years. 80 years. In a company, in a IT organization, in a company, in a company, there is an event organized. There is an event organized, right? And you're from say a event team, or you're from a HR team, and you want to order a t-shirt for all of your employees. So a team of event a team of event wants to order t-shirt for all the employees, all the employees. Now this number of employee in a company is 100,000. This is the total population. This is the total number. Let me denote this as n. So this is the total population of a company, as a number of employees are there in a company. So is it practically possible you will go to all the people and ask, what's your height, what's your height? This is a very time taking business. It's a costly operation. You cannot write out all people male, because you don't know when they'll reply you and when then you will make an order, right? So there are many questions there. Since this may take a lot of time, what we'll do, we'll try to use some sample and try to find out that how many people out of this 100k employee wears small t-shirt, how many people wear medium, large, and XL. Now if I get to know this number, then this task becomes very easy to order the number of t-shirt for this employee. Again, I can answer this question using normal distribution. I can answer this question. If I start writing, there can be a many applications where we are using this. How this engine making companies or car making companies declare that after 5 years you'll have to come for repairing or maintenance. How do they declare? So we want to calculate, we want to know. So I'm in a testing team, and we want to know, we want to calculate to know engine hours, engine hours that that they can run, they can they can run, or they can be active, they can run in between. What is the probability of this question? We want to know engine hours that they can run in between 4,500 hours to 7,000 hours. Then after that, I will ask my customer for the maintenance. Again, I can answer this question using normal distribution. So let's go and see what is the mathematical formula, or how that formula is generated for normal distribution. Now we know two things. First, how do I denote this discrete value? How do I denote this discrete value? And what is the denotation for continuous variable? What mathematical notation we have for continuous variable? For discrete, we often use px, probability of this x is nothing but my random variable, which is coming from some application, some data point. and continuous variable, which we solve using integrals and calculus, because we need to know the range. And one example I had taken last time of that rain, and we want to predict the rain of tomorrow morning 8 4 p.m. 4 a.m. So how do we calculate the rain percentage exactly? So to solve these questions continuous, we will have to go there and understand the concept of integrals calculus. Now continuous is denoted with fx. So formula for normal distribution is uh, px is equal to 1 by 1 by, and guys, please understand this notations. We keep saying from class first that what is this notation, what is other notation. So this is a standard deviation, and this is the population standard deviation. We have seen the difference between population and sample. So standard deviation is multiplied with 2 pi. We know by default value of pi, this is 3.14 into e to the power, which is exponent. And exponent e, what is the by default value of e value is 2.78. Okay, this is all mathematical calculation which is already done a way back. Exponent to the power minus 1 by 2. Okay, so your takeaway is this only, what is the formula, and then we'll see after writing this formula how that formula has been derived, or in real-time application, to find out anything, how we'll put those value in this formula, how to calculate this, and other couple of uh, mathematical arguments. So minus 1 by 2 x minus mean divided by standard deviation square. Now this formula is for normal distribution. What is this? So x, if I'm saying x is my random variable, this mu is the sigma is a standard deviation. Pi value is by default 3.14. What will be this x? So whatever random variable I want to find out, I need to know the value of that, what random variable I'll find out. So whatever value will see in question, so we'll put in place of x. Mean, this is arithmetic mean, and again we know the standard deviation. So once we get this value, we can put in a formula of normal distribution and get this. Now if you have played a game of dart, right? If you have played a game of dart, so what is that dart game? There, suppose this is my 4 coordinates, right? This is my 4 coordinates where I have x dash. This is my centroid, mean 0 value. This is y, and this is y dash. So we know this is positive side, this is positive side, this is negative side, this is also negative side. Now there are my different circles in a dart game. So say I have 3 different circles. We correct this. Okay, and we are making a hit here in a dart, and if this is the exactly where in the centroid, if I place my dart, I get a maximum point, right? And this boundary is having some point, this boundary is having some point, this boundary is also having some point. So there are my different data values, and there are 10 people, let's say, playing this dart game. So they have uh, everybody has hit hit this dart uh, 10 times. So 10 into 10, I'll say 100 different times 10 people have tried. Now I want to know the distance. How do I calculate the point, right? This all point calculation is based on this circle and based on the distance from this centroid. what is the distance, from this centroid. So if I get the distance from this to this point, I can easily calculate what is the value, because this is ultimately this point. If I check for this point, let's say if I check for this point, this is somewhere y and x are matching. This is the distance from y and this is the distance from x. So can I point this data and named as x1 and y1? Can I call this? And similarly for this also, or whatever range I have in the data, let's say there is one more data point, or there is one more data point. So distance from this, how do you count the distance in a circle? How do you count the distance in a circle? Using radius, right? You know the radius, and once you know the radius, then you can make a circle. That's what I'm going to do here. I will check what is the distance from this centroid to this point, and that point we are measuring using this point we are measuring using some theta. This is some theta, some degree, some angle. And likewise, when I start rotating my r, then I'll get a different angle. Maximum angle is 360-degree. When I start point from here and I make a whole circle and again come back here, this is a 360 circle. But here my job is to know what is the value of this radius and what theta is. This is a 30-degree, 40-degree, 60-degree, but this looks like a very much 30-degree angle data. Now if I check distance from this point to this point, this is again a radius will be similar. R value is same, only theta will change. And likewise, I can calculate all this data point, checking my fx and fy. This is fx and fy. Here I have one x, one y. Similarly, here also I have one x, one y, which can be x2 and y2. So once I calculate this, all this value, we actually get the same formula, which I have derived here. So this formula is derived is using the application of Dart. Game. How can we calculate any individual point from this distance? Because this is the zero, this is mean value, and hence we are saying any random variable coming from any data application where we are checking the data point. How can we say they are normally distributed? So first I need to fit all the data point, and if their mean is 0 and sample variance is 1. So anyways, if sample variance is 1, standard deviation is also 1. Because what is the formula for standard deviation? Standard deviation formula is root of sample variance. So what is the value of root 1? Root 1 is 1 only, right? But this denotes mean and sample or population variance. So this just remember this thing. X, how can you claim that X is a random variable when they are normally distributed with a mean and variance of 0 and 1? This is a data statistician. Second thing to take away from this normal distribution formula is this: Px is equal to 1 by standard deviation 2 pi into exponent minus 1 by 2 x minus mean divide by standard deviation whole square. And this thing is known as value of z. So whenever you will count all this concept will come one by one. So we'll calculate how to see z score. Z score is often again known as a data standardization. So whenever you standardize the data, you need to know x point, you need to know the standard deviation and mean of that data application. So when we go and see, after understanding normal distribution application, when we move to z-score, in z-score you will find this formula. This is only used in z-score. Let's see how this normal distribution can be used. So I'll take one I'll take one scenario. I'll take one example to understand this more better. So I'm saying uh, I have a coin. A fair coin or unbiased coin. Okay, and I want to flip this 10 times. a fair coin and want to flip this coin 10 times, split, let's say 10 times, okay? This number of trials you can increase anything, but just to understand the concept, first we are making a 10 trials and then we'll increase from 10 to maybe 50 or 100 or some other number. So question is a fair coin and want to flip this coin 10 times. Uh, whenever you read such question, first identify your values. So this is the value of n, and n is nothing but my number of trials. How many times I'm making a trial? I'm making 10 different trials 10 times. So I said if I get ahead, if I'm putting two scenario with this example. If I get ahead, okay, let me say h. If I get ahead, I will take a left turn. So maybe I'm standing right here, okay? Let's say I'm standing right here in this position. This position is a ion circle. So here I'm standing and I'm saying if I get ahead, I will take a left turn. I'll take a left turn. And if I get second, if I get a tail, anyways, I'm not going to get just one time. So if I get head, I'll take left turn. If I get tail, I'll take right turn. So I assume this question to understand normal distribution. Okay. Now first thing, start writing here. If I trial 10 times a coin, so my n is 10, and I'll consider any one of this, I'll consider as a success. So let me say if I'm getting head, whenever I'm getting head, I'll count this as a success. I'll count this as a success. Or I can take anything, but just for assumption, I'm taking head. If you wish, you want to take head, tail, you can take this as a success. So obviously, if you're saying head is a success, which means tail won't be considered as a success. This will come under non-success, not success. This, if this is success, this is not success. My number of trial is 10. So what is the probability whenever I flip a coin? Let's say just one time, okay? What is the probability that you get head or tail? For every trial, we are going to get 1 by 2 times. Both has a 50-50% chance. If it is a fair coin, right? We have said it's a fair coin. So probability of getting head is, where I'm taking left turn, is 1 by 2, and probability of getting tail, where I'm taking right turn, is also 1 by 2. This is my probability. Now what is the what is the value of sample variance here? What is the value of sample variance here? Sample variance, or this is often denoted as S square. Or before calculating sample variance, I will calculate what is the mean here. What is the mean here? Because mean also we need to know. What is the value of mean? So mean is total trial n into anything. If I get head also, if I get tail also, I'll get only 1 by 2. So n into 1 by 2, or I can say n into probability. Normal distribution mean has this formula, and you are going to see so many different mean with a different distribution, and all has a different formula. Do not confuse here, because in central tendency your mean is different. This formula was this. If I have 5 different x value, So I used to add all that x value, x1, x2, x3, x4, x5, and then divide by total number of x, which is n. So I used to write 5 value and divide by 5. Then I get a mean. This was for central tendency. Here I'm saying my total number of trial into the value of any probability. So any probability value is 1 by 2. So my mean will be here. My mean will be, if I solve this, n into 1 by 2, n is 10. N is 10. 10 into 1 by 2. So mean is 5. I think there's some question. Let me complete this, guys, first. Let me write the variance and standard deviation, then I'll come to see your question. Mean is 5. Now what is the value for sample variance? What is the value for sample variance? Sample variance is n into p into q. S square is equal to n total trial p. So let me say this success I'll say as a p, and this not success I'll say 1 minus p. Or the same thing in often notebook, or if you go to see this formula in a Wikipedia, this is written, this 1 minus p is written as q. So if you see q, consider it as a not success, just opposite of the event, and this is your actual event which you're looking for. So s square is equal to n into p into q. This q is nothing but 1 minus p, or this is the probability of getting head and this is the probability of getting tail. Okay, let's place this value, 10 into 1 by 2 into 1 by 2, 10 into 1 by 2 into 1 by 2. So 10 by 4, and 10 by 4 is 2.5. This is my sample variance of this question, a fair coin, and want to flip this coin 10 times. What is the sample variance? What is the sample standard deviation? Sample standard deviation formula is similar as earlier in a central tendency. This is root of s square. This is root of s square, and s square value is already known to us. This is 2.5. So can we calculate what is the value of 2.5? So root 2.5 is 1.581. So I'll keep it till third after decimal till 1000 point. So this value is 1.581. Now I was looking to collect this many things so that I can put them in my normal distribution formula and get to know the answer. What is the mean, what is the sample variance, and what is the standard deviation? Now let's see. I think a couple of questions are there. Which difference you are unable to understand, Dipesh? Can you specify a bit? There was a question for you. What difference you are unable to understand? Central tendency and this. Central tendency. Okay, so how do you, why you are using this central, why we are using the central tendency? First, we need to know the question part. What is the question? If question is coming that you want to take 50 data point from a city, right? Let me put this another way. So you want to calculate you want to calculate calculate average let's put um, average weight of the city. of the city, right? The city can be anything where we have millions of population. So how do you calculate this? This is my main city where I have 1 million population, where I have 1 million population. So will we visit one by one to 1 million house and ask, sir, what's your weight? Is it practically possible? This is practically possible. Practically possible, this is not. And hence what we decide to take a sample set from this. So this 1 million thing, I can say this is the total population. This is the total population. And here I'm saying I will take sample of it. I'll take sample of it, right? And then taking sample of this. So out of 5 million, I have collected only 100 data points. 100 data point from the city. And obviously this is a randomly sampled data. I'm not going to get this data from just one corner of the city. I'm randomly selecting, which means this all 1 million people have an equal chance to be selected. All this 1 million people have a uniform chance to get a selection in the random number of selection. I'm not biased towards the selection that I'm saying only I will get the city from this urban location. I'll not go to the rural, or I'll not go to this area. I'm taking the sample from the whole area, and maybe I'm taking 5 people, 2 people, 3 people, 8 people, and likewise I have get this 100 data point. Now 100 data point means I have collected xi's. I've collected so many xi's, and this xi is nothing but this is x1, x2, x3, x4. These are actual people, number of people where you have calculated the weight, plus x 100. This is having some weight in a kg or in a lbs. So this is, let's say, 58.2. This is having 63.9. This is having 74 kg. This is having 50.1. And likewise I have so many data point there. I have some 70.5, and this x100 is having 82.1. Likewise I have random data, 100 different data point. When I write all the data point one by one and divide them by total number, this is nothing but my x bar. And x bar is known as a sample mean. I am using sample word. This is important to mention, that you have taken a sample from this whole population. This is what is the concept of central tendency. Whenever we have a so much data point and we want to get the arithmetic mean, we apply this concept. This was the central tendency, but now I'm putting the same scenario in different case. I'm saying I have a coin where I take a trial of 10 times or maybe 20 times, and what is the chance of getting head or tail, right? So when I put this question, when I put the second question, there is a coin, or there's a dice, so it's a coin only, and a coin. Take a trial of 10 times. Two question can be there. First question, two question can be there. First question, and guys, to understand these questions more better, I have given you a one good website. So please go there, write statistics, and take some question from this site. This is an open source site, because to solve this problem statement and understand where we can apply, just to using one or two question which I'm giving you as example cannot be clear whole thought. So please go there and see a couple of example from individual topics. So all the topic is there. You just need to go down, type statistics, and get the question. uh, Strongly recommending this. Okay, so if you want to understand whole concept, we will have to visit. I take many questions from here, I take many examples from here. Okay, so things can be on same page. First question is that what is the probability of getting head, and what is the probability of getting tail in all this 10 trial? Every time all this probability is 1 by 2, 1 by 2. But if I say what is the probability, what is the probability that we get that we get exactly four tells. If I put this question, this is uniform distribution. This is a uniform distribution. And why this is a uniform distribution? Because I am saying for all the trial, what is the chance of getting head and tail? So practically you take a coin and you think when you flip it, both has a 50-50% chance for every single trial. But my second question is different. Here I only want to know what is the probability of getting tails four times. I don't care how many heads is coming. I only care about the tails. Now, if I want to calculate mean of this, okay, if I want to calculate the mean of this, first thing, this we need to understand whenever question is coming, this question is coming from which kind of distribution. I cannot directly apply a central tendency, normal distribution, Pareto distribution, sampling, T, Z. You'll encounter 10 to 12 distributions in coming sessions. So to understand this problem statement, I need to know what is the distribution. And once I know the distribution, then I think immediately, okay, this is a binomial, because we are doing the same task, same event multiple times, again and again. I'm flipping the coin again and again, and then asking what is the probability of getting 4 tail. Immediately I think this is not the uniform where I'm doing just one time. I'm doing this multiple time, hence it is biform, and that biform distribution is known as a binomial distribution. Immediately when I get to know that this is a binomial distribution, immediately I think, okay, I need to know the formula of binomial, which is px is equal to n chooses k, n chooses k, n is number of trial, k is my number of tells which I'm getting. This is my success. This is only for tell, and this formula is coming from uh, combinatorics, permutations and combinations, right? And then we calculate what is the probability of getting tell, because I'll consider this tell as a success now. Whatever is coming in the question, consider it as a success. So if I'm saying this is a success, and what is the probability of getting k? If I get k times tell, which means I get 1 point p times n minus k. This was for the binomial distribution. Okay, so first you need to understand what distribution this is. Then we go to the formula, and then we try to understand how can we put, because before putting these values, I need to know what is the value of n, what is the value of p, what is the value of k, what is the value of 1 minus p. Then only I can fit in this formula and get to know the answer. So all the distribution is having different. Here we are trying to understand normal distribution, because do you have any 10 times x? Do you find 50x different here? So obviously you cannot use the arithmetic mean here. Now suppose this is my point, this is my ion circle where I'm standing, and I'm saying when I get a head, I'll take a left turn, I'll take turn this side. This is my, say, left, and this is my right. So when I take head, I'll take left. When I get tail, I'll take right turn. So if I get 2 times head in all 10 trials, so I flipped my coin 10 times and I get 2 times head and 8 times tail. Okay, this is my number of outcome after flipping coins 10 times. I have collected all this value, whether I'm getting head or tail. So I want to know from you guys, what will be my end position? What will be my end position? Where I'll stop? Will I be 2 times towards left, or 5 times towards right, or 7 times towards right? What is my end position here? If I get such event, such answer of after 10 trial, then where is my end position here? Any thought? So end position means, guys, let's say first I flip a coin first time. This is my first trial. I get a head. So when I get a head, I'm taking left turn. This is my position. Let me write in a different color. This is my central. This is the zero. This is zero. Okay. And when I get a left, I'll say green. So this is my one head because I'm saying head means left. I get second time also head. So second time is also head. Again, I'll take one more turn, one more step there. Then I get tail. I get tail. So my position is currently here. Again, if I get tail, which means I need to go right side. I need to go this side, right? But this is my current position. So after getting one tail, I'll reach here again. Then one more tail in fourth trial. So again, I go to central, which is zero, because this scenario is two head, two tail. I took two steps towards left, and then immediately I took two steps towards right. And this is my central area. Again, I reach to zero. Then I'm getting 1, 2, 3, 4, 5, 6 times tail. So 1, 2, 3, 4, 5, 6. Here I can say my end position is towards towards right towards right six times or sixth step. This is the outcome of this. Are we clear? Because guys, where I'm standing, I consider that as a central area. That is my zero. And when I'm getting head, I'm getting left turn. When I'm getting tail, I'm taking a right turn, and then one step each time. So total 10 times trial, 10 is outcome. 2 times left, again 2 times right. So you reach here, and 6 more times red. Okay, so there is another question. Uh, my video is paused. Dipesh is saying, I think Dipesh, there's problem with your network, because nobody has complained me for this. So please check your network, refresh, and again reconnect. Yeah. So is this clear? Is this clear? And I will calculate this also. So after this, if this particular part is clear, so I'll have one question, and if try to give answer for that. Okay, try to give answer for that. So my position my position is now I'll change my event. Okay, I'll change my number of outcomes which I get here. I'll mix my data set. So I get total first time tail, head, head, tail, tail, head, tail, tail, tail. Uh, three, one more time. Let's say head. When every time I flip the coin, I get 10 outcomes again. I get 10 outcomes again. This formula will be clear, Dipesh, once I go there and place the value of one event, second event, third event. So let me first solve this with that formula, and then if still that question is unclear, we'll again revisit that part. So after 10 trials, I'm getting how many tails total? 1, 2, 3, 4, 5, 6, and 4 times head. So can you guys calculate and tell me if this is my standing position, there I'm standing in a static mode, and then I decided, so obviously when I'm standing there, I'll consider this as zero, right? This is zero. And what is my end position now? Can you guys tell me what is my end position now? Where I should be in left side or right side, and how many step? So, all right, there is one answer, right answer. Thank you. If I'm standing here and I take first I'm getting tail. So when I'm getting tail, I'll take this turn. Second position to right. Okay, I'll save this answer and I'll revisit again to see this, guys. I think two answer is right here out of three. So other also please answer if you know, whether don't know. We are not looking for right answer again here. If your in question is again coming, we'll solve it again from taking different example. But to understand this normal distribution is again very important, because this is the 33.3% of your statistics. Keep in mind, this is 33.3% of statistics which we are using. So my in position is, when I get tail, I take turn there. When I get head, again I come back here. Again I get head, I go towards left. I again get a tail. Again I go there. So till this, my position is 0. Simple. 2 head, 2 tail, my position will be 0 only. One more tail, which means again right. So again I'm here. Again I am here. I get head. Again I reach to the central area 0. I get again tail. Again I reach here. I get again tail. I reach here. I get one more tail. I reach here. I get one more head. I reach here. So this is my final point, final end position, which means I think two answer is right here. People who have given two step towards right, two step towards right. And why I'm taking this example, guys, to to apply this concept on normal distribution. And how we are applying this, I'll write this new value, all this value in my new cell. What is the value of mean is 5. What is the value of sample variance is 2.5, and what is the value of a standard deviation is 1.58581. 1.581. Now this is my end position, this is my end position, this is my left, this is my number of step towards right. This is there I'll calculate what is the value of binomial distribution for the same event, and what is the value of normal distribution for this event, right? So if I get all 10 times tell, if I get all 10 times tell 0 head, so my position is here. If I get all 10 times head, okay, if I get all 10 times head, I'll be somewhere here in the 10th step. So I'll be here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, my position is here because I get all the times tell. I get all the times tell, which means 10 right, my position is towards right 10 step, and 0 towards left. What is my end position? My end position is 10 towards right. And I want to calculate for this, let's say for 0 step towards left. I consider this as my x. I consider this as my axis because left I'm considering as my success. So I need to know what is the probability or what is the value of normal distribution that I do not get any head. What is the value of this? So first we'll calculate what is the binomial distribution. What is the binomial distribution for probability of x? And first I'll write a formula. So n c k, n chooses k into p, which is left. Probability of this is k into 1 minus p, not success, as in tell. And if I subtract total number of success by total number of trial, then this is not success probability. I'm considering this x is 0, equal to 0. So what is your value of n? N is total 10. I flip coin 10 times. My number of trial is 10. And how many times I'm getting? How many times I'm getting left? As in how many times I'm getting head? So I'm getting head 0 times. So can I say this is 10c0? Can I say x is equal to 0? This is what I'm finding. 10c0, my number of head is 0, 0 success, into what is the probability of getting, what is the probability of getting head and what is the probability of getting tail? Both are 1 by 2 and 1 by 2. So head is p, which is success, and tail is 1 minus p, which is not success. That I have assumed in this question. In this question, head is a success and tail is a not success. Into p, p is 1 by 2. P for head is 1 by 2. And how many times did you get this? 0 times. You get this 0 time into 1 minus p. What is the probability of getting tail? Is 1 by 2 to the power n is 10, and 10 minus k. K is a success. Did you get any time head? No. So 1 by 2 to the power 10. If I solve this, I will get to know the binomial distribution, the probability of this getting. Probability of getting 0 head in this question. So 10c0 can be this answer will be 1 by 2 the power 10. I guess 1028 something. So let me solve this using the factorial concept. 10 factorial into 10 minus 0 factorial and 0 factorial. So 0 factorial into 10 factorial. This anyways become 1. 1 by 2 the power 0, any value to the power 0 is 1, into 1 by 2 the power 10. So 1 by 2 the power 10. Probability of this will be 1 by 1028. And if I solve this 1 by 1028, let me solve it for 1. Then maybe for one event I'll give one question. Start solving that. 1 by 1028 is 0.000972. This value is 0.00097. Let me reiterate this whole scenario. Okay, what I did here, I'm standing here, and I said if I get a left, if I get a head, I'll take towards this side. If I get a tail, I'll take a turn towards this side. One step each time. Okay, and then I said I get 0 time head and I get all the times tail, which means my end position is towards right 10 step. Since I'm counting this head as a success, I need to know the probability value of binomial distribution, that if there is a 0 time head coming, if there is 0 time head coming, all the times tail coming, so what is the value of x for such event? And then if I check for normal distribution, what is the value of normal distribution for getting 0 time head all the times tail? And then after collecting this value, I will plot this data using visualized format, and you will found that this curve will be looking as a bell curve. This curve will be looking as a bell curve. This is a calculation for probability of binomial distribution. What is for normal distribution for same event? If I calculate it for px is equal to px is equal to uh, x is equal to 0, and I'll apply same formula for normal distribution. 1 by standard deviation square root 2 pi into exponent e to the power minus 1 by 2 x minus mean divided by standard deviation whole square. I know value of this. I know exponent value also. This is 2.78. You can follow some chart of exponent and you can get to know the answer of this. What is the e to the power 1, e to the power 2? Here we'll calculate this. What is the value of x? This x is 0. Mean 5. Standard deviation, I do not have value for this. This is a big concern. I don't have value for standard deviation. But since I have a sample data available, this is what? This S is sample standard deviation, right? So if I do not have a whole population data, just like I have taken example here, when you want to check the weight of the whole city of 1 million population, since this is not practically possible to visit all the people and ask their weight, what you decided to do, you try to follow the approach of sample concept, that I will take 100 different sample, I will add all of 100 values, divide by 100, and then I can answer that what is the, this is nearly, this value is nearly similar as value of this. This is my sample mean, this is my sample mean, and this is my population mean. But this is very costly business, time taking business. That's why I decided to take a sample, right? So can I say this value is very similar as this? This tilde sign is for what? Tilde sign is for very similar. Not exactly similar, but very, very similar. And the more number of this point I will take, the more number of sample I will take, this accuracy will be nearer towards this mean. If I take 100, suppose this value is 11.04, and this mean value, and this is, I'm just assuming, this is a big let, okay? When I calculate, this value is coming as, so let's take a logical number. What can be average mean of people from a city? So let's say mean is 54.5 kg. This is of 100 sample, guys. And when I'm checking the whole population, whole 1 million people using government census data, then this mean is coming as 58.3 kg. Okay, and here I'm saying they are nearly similar, not exactly similar, but nearly similar using this sign. If I take a second scenario, and there I say, instead of taking 100 people sample, if I start taking 1000 people sample, if I take 1000 sample, will this go towards 58.3? It will be more nearer to this. Do you agree with this? Do you agree with this point, that if I increase the number of sample, this is the whole concept of statistics. When you increase your sample, your accuracy is more better. If I just give you 10 data point and then I'll ask you what's your accuracy, you can tell me any bias number. I cannot rely on 10 data point. I cannot rely on 50 data point, 100 data point. That's why I'm giving you more sample. So out of this whole city, then again I decided to take 1000 sample, and this is my 1000 sample. So this 1000 sample mean, whenever you calculate, will go after understanding the whole concept, while writing this in Python or while applying this on algorithm, you'll find that whenever you take 100 sample and when you take 1000 sample, anytime this is much nearer, this is much nearer to your population mean. Okay, so that is one reason I'm keep saying since our class first, that why this big data part is very important for artificial intelligence, machine learning, and machine learning and deep learning. Because if you do not have a data, if you do not have a data point, then what you will calculate, how you will make a prediction? If this is not there, you can't make any prediction. If I have 100 sample, my accuracy is, let's say, 90%. If I have 1000 sample, my accuracy is 92%. If I have 1 million sample, my accuracy is much nearer to the mean. This is what is directly proportional, and hence we call data is directly proportional to predictive analysis or any kind of predictions. The more you have data, the more is your prediction, the better is accuracy. So I hope this point is clear, and that's what I will do here. I do not have a value of sample standard. I don't have a value of standard deviation, the mean of this. So can I say this is nearly similar as this? If I don't have value for this, can I take this value and count as a mean? We will have to do that. We don't have any other choice. This is what is the concept of sample and population. Whenever you are unable to calculate the population, take the sample and calculate it and get the number. And that is why we are using the big term here called prediction. Whenever you use this term, this word itself is saying that I'm not 100% sure, I'm not 100% accurate. I am I'm accurate with some percentage, some confidence interval. So if I don't have value for this, can I take a value of this? Can I take a value of this and place here? So 1 by standard deviation, and standard deviation value is 0. Western deviation value is 1.581. Since this is for sample, but still I'll consider and use 581 into 2 pi. Pi value is 3.14. If I multiply with 2, I'll get 6.28. And what is 6.28 square root? 6.28, 2.5059. So I'll keep it till after decimal 2 point. I'll say 51. Okay, 2.51, because it was 505, so I took only till 2 decimal, into e to the power exponent minus 1 by 2. What is the value of this x? This x is 0. You're checking for this left. This x is 0 minus, what is the mean? Mean is 5. Mean is 5. And standard deviation is 1.581 square. You can solve first this part. You can solve them in a part wise. So solve this part first, part 1. And to solve this all, in your normal mobile, you cannot calculate them. Normal calculator will not provide you such facility. So you need a scientific calculator. Those we have used in college times. So scientific calculator is one. And second, people who are using mobile application, so they can download let me see, what is uh, the calculator name? It's, I think, scientific calculator, hyper scientific calculator. Please note the name. Download this hyper scientific calculator from the app store. So you'll get this and you can download, then this calculation can be easily done. So we'll get some value here. Okay, my agenda is not to calculate the value. My agenda is to first prove the bell curve, how the bell curve is coming, how we can plot the data using any Excel or using any pie chart or using any Python library. And like this, I'm keep calculating till 10 times. Let's say I took a 10 different trials. That's what I said. So first time I'm getting 0 times, 0 times left, 0 times head, and 10 times tail. Second, I get 1 time left, 1 time, sorry, I'm keep confusing with the left and head. So 1 time I'm getting head, and 9 times I'm getting tail. Can you tell me end position towards where? If I'm getting one time head, guys, please respond here if you know the answer. If you're getting one time head and 9 times tail, what is your end position and towards where? I think this is easy to calculate. Just make yourself standing here, call this as 0, say this is left, this is right, and start taking a step. I said one time head you are getting, which means you are going left, and all the times you're getting 9, which means again you're going back here. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. What is your end position? 1, 2, 3, 4, 5, 6, 7, 8. Your end position is here, 8 towards right. Please do that. So my end position will be, my end position will be 9 minus 1, which is 8. 9 minus 1 is 8. And again I can solve using binomial distribution formula and normal distribution. This time I'll consider my head is 1 and x probability of 1 I'm checking. If I get 2 times head and 8 times right, I'll leave this for you. If you're able to solve, please reply me with your answer. I'll write according to you. If not, I'll solve by myself. 3 left, 7 right, which means 3 head and 7 tail. 4 head, 6 tail, 5 head, 5 tail, 6 head, 4 tail, 7 head, 3 tail, 8 head, 2 tail, 9 head, 1 tail, 10 head, 0 tail. This is what is occurrence of my 10 different trials. Okay, so every time my end position will change. This is towards right, so let me say this is towards right, this is towards right, and 9 minus 1, 8, 8 minus 2, 6, 7 minus 3, 4, 6 minus 4, 2, 5 minus 5, 0. This is the area, this is the area where you are standing. This is the area where you're standing, the 0th value. 4 minus 6, minus 2, 3 minus 7, minus 4, 2 minus 8, minus 6, 1 minus 9, minus 8, 0 minus 10 is minus 10. This is what is my end position. If I write this is right, this is right, this is right, this is nowhere, this is my neutral position. I'll say neutral. This is my left, 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 left. Now 0. So here I have 2, my end position as 2, minus 2, 2, 4, 6, 8, 10. This is towards right, and minus 2, minus 4, minus 6, minus 8, minus 10. This is towards left. I've just written the end position there. Okay, and this is my neutral. This is my neutral. Let me highlight this. This is my neutral area. Now what this theory of normal distribution claim, that whatever value of 2 and minus 2, whenever your position is 2 and minus 2, this normal distribution value will be exactly similar. For this event, and this event, the value will be exactly similar. For this event and this event, when you are 4 step towards right and 4 step towards left, this is exactly similar. Even your decimal points are also very very similar. There is no .0001% of chance of difference also. if you take a value of 10 towards right side, and if you take a value of 10 towards left side, this is again exactly same. So what this bell curve normal distribution theory is claiming you, that these values are symmetrical. These values are symmetrical. If I create a line in my central area and I start plotting whatever point I'm getting, so this 0, let's mark here 1, 2, 3, 4, 5, maximum probability. So this probability will look like this. This probability will be looking like this. Let me create a histogram for you. So this will be keep increasing mode. This will be keep increasing mode, and same, I'll strongly recommend for you people, take as x value of 0 and take a x value of minus 10. Take a x value of 10, or let's say take a x value of 3, which is in position 4, and take a x value of take a x value of 7 when your end position is minus 4 and 4 and minus 4. Whenever you calculate for x is equal to 3 and x is equal to 7, normal distribution and binomial distribution, this both value is exactly similar. Probability of this is what normal distribution uh, concept is built on. And again, I'll have a big tower here. So let me create a histogram, and then I'll start mapping. I'm trying to get as I'm just trying to get this probability similar. Okay, and after this I will open one Excel sheet, and then in that Excel sheet I have written some of the I created some of the graph that I'll show you. This is how this probability will look like. This is what my visualization will be there, and when I start adding them, it will be very similar in a growing, and then it will be neutral, and then this value will be look like this. This is what my curve will look like when I solve this problem statement. And what normal distribution theory is claiming, that whatever value I have towards left side and whatever value or probability I'm getting towards right side, this is exactly symmetrical. They are symmetric value. And what do you understand by symmetric value? Whatever value is there, the same value you have here also. Whatever value is there for minus 4, the same value you have here also for 4. Whatever value you have in minus 6, the same value, exactly similar value you have in 6. Minus 8, 8, minus 10, 10. Okay. And using this visualization concept, there is new theorem built. There is new theorem built to answer such interval question, that what is the average lion life in a zoo, or not average, what is the lion life in a zoo in between 40 years, how many lion lives in between 40 years to 60 years, what is the average mean of the engine, what is the average CPM of the black box. Okay, so this question we can solve using the rule of empirical rule. This empirical rule is built on the concept of normal distribution only, on this only. Empirical rule is also known as 68. I think while taking our first statistic class, while discussing the central tendency, I had introduced this, and I said that time that when right time will come, then we'll discuss about the empirical rule. So today we'll see a couple of applications how this question can be solved. Empirical rule 68, 95, and 99.7% rule. This rule is also known as a 68, 95, 99.7. Now, what is this value for? Where we are using this value? Let's create first. Let's create first normal distribution plot. So x and y, and this is how my data is normally distributed. This is how my data is normally distributed. Okay. And we know that how do we claim that x is a normal x is a random variable which follows normal distribution concept if it is having 0 as a mean and 1 as a variance. This is my mean, this is my mean, which is 0, which is 0. This is my mean, and empirical rule theory says one standard deviation away from the mean. Focus guys here. One standard deviation away from the mean. When I say away from the mean, you consider towards this. When I say below, consider towards this side. As an again, right and left. You can take this as a right, this as a left. So first I'm saying one standard deviation away from the mean, which is this point, uh, mean plus standard deviation. One standard deviation away from this point and one standard deviation below from this point. One standard deviation above from this mean and one standard deviation below from this mean. This area, because if I ask you what is the total probability of this area, this whole curve is maximum, any probability can be maximum 1, any probability can be maximum 1, not more than that, right? Any probability values varies between 0 to 1. This is what is the whole concept of probability. So I'm saying this whole area is 1 where my standard deviation is away from the mean and one standard deviation is below from the mean. This whole area is how much? Looking at this number, this area is how much? This area is 68% of the total probability. Whatever question you are asking, the total probability of that area, when you know the mean and when you know the standard deviation, and you are claiming that that distribution is coming from normal distribution, so you can easily calculate this interval. You can calculate this point and this point, and this point is 68%. This area is 68% of the total probability of any question. After knowing this, we'll go to CK12 and see a couple of examples there. When I'm saying this whole area is 68%, and according to normal distribution concept, this is following the concept of symmetrical rule. They are all symmetrical data. So this is 34% and this is 34%. If this whole area is 68%, so can I say one side is 34 and another side is 34? Because if I add this, if I aggregate this, I'll get 68%, isn't it? Second theory, mean minus standard deviation. Just concise it, yeah. Now second thing, when your mean, so between this area is how much percent? 68%. That's what you get it from here. Now when your standard deviation is away, two standard deviation is away from the mean. Two standard deviation away from the mean means mu plus two standard deviation, mean plus two standard deviation, and mean minus two standard deviation. So away and below, two times from the mean. This area, this entire area from here to here, this whole point I'm considering, okay, this whole point is how much? Is 95? This whole area is 95. Since you have already calculated the 68, how much is pending? 95 minus 68. 95 minus 68 is equal to 27. if you divide this 27, because you are saying symmetrical data, so this side also you have the similar total area, a similar percentage, and this side also you'll have a similar percentage. So 27 by 2 can be also written as 13.5%. Can I say that? So this area is 13.5%, and this area is also 13.5% till 2 standard deviation away from the mean and below the mean. So you have calculated 1 standard deviation away and below, 2 standard deviation away and below, and I'll write it here. Mean plus 2 standard deviation to mean minus 2 standard deviation. Guys, I think there is a rain started. I don't know whether if electricity goes on, we may be disconnected. So uh, keep in mind if I probably disconnect after some time, so there's a rain happening. Okay. All right. This area is 95%. Now, third standard deviation, because we have value till third, is third standard deviation above from the mean, which means this area mu plus 3 standard deviation, and mean minus 3 standard deviation, and mean minus 3 standard deviation. This is mean minus 2 standard deviation, and this is mean minus 3 standard deviation. This area is how much? Out of 99.7%, already you have calculated 95%. So if you subtract 99.7 minus 95, what is your value? 4.7. And if you divide 4.7 symmetrically, you'll get 2.35 and 2.35. Mean plus 3 standard deviation to mean minus 3 standard deviation. This area is 99.7%. So we have calculated till 99.7%, and we know if we know the value of mean and standard deviation, we can calculate any question using this concept, empirical rule. But total probability we are claiming is 1, which is 100%. This is a p-value, probability value. If I convert this in a percentage, I'll multiply with 100 and I'll say 100%. So out of 100%, you have calculated 99.7. How much remaining? 0.3% is remaining, right? 0.3% is remaining. 100% minus 99.7, 3.000. So 0.003, you can write this as 0.15%, 0.15% this side, and 0.15% this side. If I add all this point, this all is equal to, this whole area is equal to 100% maximum probability. So symmetrically this is distributed, and when we know that that data is normally distributed, so we can answer a couple of questions. And question is coming right here. Question is coming after this. So I'm solving a question from a Jew. In a Jew, how many lion in a Jew if mean life, average life, mean means arithmetic mean, average life of lion is 47 years. Okay, in a Jew, if mean life of lion is 47 years, with with a standard deviation with a standard deviation of with a standard deviation of 3 with a standard deviation of 3. So how many lion live in between in between 41 years to 50 years? This is my question. Can anyone try solving this problem? This problem can be solved using normal distribution concept and empirical rule, or I can directly solve the empirical rule, because I, while writing the empirical rule formula, I said if I know this two thing, if I know this mean and a standard deviation, I can solve any question. So just a hint for you guys, mean is here in front of you, which is 47 years, and standard deviation is also there in front of you, which is 3. So can you guys tell me what is the life what is the life of lion in between 41 years to 50 years? Can anyone calculate me this? Or tell me approach at least. So you know this percentage, you know the mean, you know the total area also, 34%, 34%, which is 68 aggregated, 95, 99.7. I'll give 2 minutes. If you're able to solve, it's good. If not, I'll explain. So no answer. Are you guys even trying? Okay, so let me tell this. I think everything is in front of you. Just need to go a little bit of previous concept of this, and then you'll get this. So what we claimed here, what we claimed there, that if this question is coming from a normal distribution, that we are saying that this data is coming from the normal distribution. So empirical rule can solve this big problem just in a minute. How? It is saying 41 and 50 years, right? So let me draw one visualization graph for you, which is X, which is Y, and this is my normally distributed area. Normal distribution looks like this only. So this is my normally distributed area, and we know this is mean. If we are claiming that this is normal coming from normally distributed, this is my mean, and mean is given as 47. Mean is given as 47. Mean is given as 47. One standard deviation away from the mean. Okay, one standard deviation away from the mean means this area is mu plus sigma. This area is mu plus sigma, and one standard deviation below the mean is mu minus sigma, right? And we say that this area is how much? 68%. This area is how much? 68%. We have seen here this area, the first area, one standard deviation above and below is 68%. So we know the mean. If I add 47 plus 3, if I add 47 plus 3, how much value will get here? 50. This point is 50. If you subtract 3 by mean, then this is 47 minus 3, which is 44, right? And what is the value of this area? This area is 68%. This area is 68% that we know so far. Okay. Second, if I subtract, so this point is clear because the question is, what is the average life of lion? How many lion live in between 41 to 50? So maximum year was 50. I reached to 50 already. I will not count this side now because my maximum 50 is counted already. Now I'll go towards below value of 44 because I need to check from 41 to 50. I have reached to 50 already. Now let me calculate one more time to know if I subtract one more time, which is 2 standard deviation below from the mean. Please focus here, guys. This is very important rule. We are using this in many data science applications. 2 standard deviation below from the mean. 2 standard deviation below from the mean, and we have claimed that this area is how much? If you go 2 standard deviation above from the mean and 2 standard deviation below from the mean, then this area is 95. We have claiming that. So I'm not counting this side, I'm just counting this side. So 13.5, this area is not counted. This area is how much? How much this area is? What is the value of this point to this point? How much area? You just need to write the percentage here. 13.5%, right? This is 13.5. So this is 68%. This is 13.5%. And if I subtract 47 minus 6, what I get? If I subtract 47 minus 6, I get 41. And this is what was my question. How many lion live in between this? How many lion live in between 41 years to 50 years? So my answer is here. 68 plus 68% plus 13.5% of lion live in between, which means 81.5% of lion live in between 41 years to 50 years. Say, I know the population of Jew. I know the lion population in this Jew. So total population of lion. If total population of lion is 8,000 in this Jew, then can you tell me how many lions? Can you guys tell me? So I have already calculated the total life of lion. That 81.5% lion lives their life in between 41 years to 50 years. My question is second, can you tell me the lion number if there are total 8,000 lions? So simple, 8,000 into 81.5%. What is the value of this? So to solve this, I will use a calculator. 8,000 into 81.5 into 81.5, 6,520 lion, 6,520 lion lives their life in between 41 years to 50 years. Is this question clear? If not, please tell me. I'll reiterate again because we are going to see many questions in this empirical rules. Is this concept clear? Can we calculate now second question, or if such question we see coming from same concept or same method? Yes, no? Okay. Now I'll go and solve some question from CK12 website. So let's go to CK12. Type statistics. Click there. Check your topic. We are reading this empirical rule. So let's go to empirical rule. And click on practice. So this is open source site. Questions are good here. So they're asking me to sign in. Sign in using Twitter. So in my account, actually, it is directly taking me to. Okay, so actually this is directly extracting my account. So I'll do. I think let's do one thing. Because it will continue from the question which I have already completed, so you won't be able to see the beginner questions. Those are questions coming from different topics. So you guys can create also your account, okay, and log in with the Gmail, Facebook, or Twitter, and then we can see the question from beginning. So in that case, let me create some other question. In a in a uh, in an insurance company, in an insurance firm, we want to take insurance. We want to take insurance for vehicle. For vehicle. So find us if mean is given. if mean is given as if mean is given as 57 hours, if mean is given as 57 hours with the standard deviation, with a standard deviation of 2.5. Okay, so how many uh, how many how many percentage, or what percentage of car engine works more than more than 63 hours. So average engine life we know is 57 hours with a standard deviation of 2.5, and we are saying what is the, if you're going to take a insurance for the vehicle, what is the total percentage of car works more than 63 hours. So you just need to tell me the percentage of car. Again, we can solve this using the same concept, of empirical rule. I'll again draw this x and y. This is my x, this is my y, and this is the area. This is the area. This is my mean. What is the mean here? 57 hours. So mean is 57 with standard deviation 2.5. And they're asking me more than 63. So I need to check this side because they're not asking me in between, or they're not asking me less than 57 also. So the question is more than 63 hours. I need to check this. More than 63, when I'll get. So if I add my mean with the standard deviation 2.5, one standard deviation, this area, this value will be 59.5, right? 58, 59.5. Then second time again, if I add, this will be, so just make one changes in a question. This is 62 years. Okay, 62 hours. 57, 59.5, and if I add one more time standard deviation, this will be 59.5 plus 2.5 is 62. Okay, again empirical rule. This area is how much? So one standard deviation above and below was 68, 34, 34. So this area is 34%. This area is 13.5%. So 34, 13.5. How many values I have in between here? Because this is starting from 0. So 0 to 62, what total percentage is there? What is the total area of this from 0 to 62? What is the total area of this? So this area is, because this side is also 34% symmetrical. This is 13.5%. This is 2.35%. I'm referring this one, guys. Now I'm referring this. Symmetrical rule of empirical, that 68, 95, and 99.7. I'm using this rule. So where is the question? Okay, 2.35. Now if I add 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5, if you add this, how much value you're getting? how much value we're getting. So already I know 2 standard deviation above and below is 95. If I add 95.15, if I add 95 plus 0.15, this is how much? 95.15% from this point to this point. And question is, what percentage of car engine works more than this? So I need to find out more than this hours. So more than this is what? 100 minus this. So answer for this question, this R is 4.85% of car works more than 62 hours. If I have such data, this is my answer, 4.85%. So this kind of question can come in CK12. There are many questions like this. Go there, solve them. If any question is coming from normal distribution or empirical rule, we'll see them tomorrow. Or you can mail me also your questions. Then we'll see. So after empirical rule and normal distribution, tomorrow we'll see sampling distribution, expected value, and couple of other concepts. So this is it for today, guys. See you tomorrow in the same time.